Okay, I think we're live. Good
Cool.
morning, good evening, whatever you are joining in today. Hi, Ted. How are you?
Hi, Lisa. I'm doing well. How are you?
Good, thank you. How is Canada? Remember, where are you connecting from?
Yeah, we got our Canada coffee here, ready to go. Timmy's, shout out. Yeah, it's a kind of a gloomy day over here. It's noon right now. I know it's morning over in your time zone.
It's 9 a.m. from in California and another sunny day, as per usual.
Of course.
So while people connect to into the live, why don't we? Because Ted and I met in person in commercial UAV a few weeks ago, which was amazing. So let's do overrated, underrated commercial UAV this year.
Yeah, well, actually, it was my first time at that conference, and I
Mhm.
think I picked a good year to go because it was absolutely packed. There were so many people, um, and a lot of cool new things. I'll give you my overrated first. This is probably going to be a little bit controversial, but
Go
I
for
don't
it.
care. Yeah, my overrated that I saw is aerial lidar. I just saw way so many booths with a lidar sensor, uh, and I'm over here thinking, okay, like that's awesome, but do we need this many, manufacturers of the same thing? Because it's just the same sensor and the same INS, just in a different package most of the time. So, eh, that was
Interesting. Okay,
yeah, yeah.
lighter, overrated.
Yeah, yeah, and I'm a big photogrammetry guy, so I
Yeah,
might be
no,
biased.
we know that. We should definitely do a bit of a comparison between LiDAR and
Yeah,
photogrammetry. I think you're working on that, so that'll be
yeah.
something I'll be waiting to see on your LinkedIn. And how about underrated?
Underrated, I'd say software solutions,
Mm,
specifically for like visualizing 3D data. We have a hard
interesting.
we have a hard time sharing 3D data, I think. Everybody still wants
Yeah,
PDFs, right? And there's a reason for that. Like PDFs are just easy to share. We need 3D data to be that easy because we can make it much faster than people are demanding it at this time, I think.
amazing. Okay, well, thanks for
Mhm.
that.
How about you?
Oh, okay. Overrated. I think Vegas was a big disappointment for me.
It always
I
is.
think I was very vocal about this. But yeah, it was a. I don't know why any company or industry will do a business event in Vegas, to be honest.
Yeah.
And also as a woman, it was a no go
Mm.
for me. Underrated, I will agree. Software was and got a couple of new software platforms I didn't know, so that was yeah very
Hmm.
interesting.
Yeah.
Yeah. Cool. Let's talk about breach inspections. We've been waiting. A lot of people have been waiting for this webinar. There's been a lot of interest. I was myself on site with Caltrans last week, which was super interesting to see like the real environment where this happens, which is just yeah,
Yeah,
like
it's a different place, right? It's not like a regular construction site or a place you
hmm
would be flying a drone.
yeah,
It's very weird.
yeah.
Um,
So you've been doing breach inspections for a while now, Ted. How did you get into this and walk us through, kind of like as a
yeah,
drone service provider in Canada?
yeah. So we're a drone service provider, so we do the boots on the ground bit and the data side. The bridge you're seeing on the screen here is actually the first one we inspected with a drone, and that was we're very like thankful to have some amazing clients like Macintosh Perry. And this was actually the first time that the Ministry of Transportation, basically our DOT here, did a full scale, complete just drone bridge inspection.
Hmm.
So we learned a lot from that, and then that was 2 years ago, and we've been doing them ever since for both Macintosh Perry and Ontario, and we keep learning more. Like again, bridges are my favorite because they're just so different every time, and they're so complex. And
Hmm.
they're also so vital to our infrastructure. There's just so many of them.
Yeah.
So that's
So
basically
show
how we
us.
started.
Yeah. Do you have like any kind of like examples of the type of breaches you've been inspecting in the last
Yeah, I got about 5. So this is the stuff that I'll go through in the presentation, and there's a lot to talk about on this subject. So I think we're probably going to break this up into 2 webinars. This first one will focus on the data collection because I think
Hmm.
that's where it all starts. You got to collect good data. So this is an example of a bridge. This is on a major highway in Toronto, 5 lanes, and you can see this is a what we call a slab on concrete girder. So actually a fairly new type of construction and fairly easy to inspect. But then on the other side of it, we have this 6 lane going the opposite way. And this is an older construction, so probably about 20, 25 years. And this is what we call an open spandrel concrete arch. So we have some data from this to share. We also did this one. This is a smaller municipal road. And
Mm.
again, that older construction style, you can see the open spandrels and the arch. And we actually did a
And the
lot of
water,
the
like has,
water
yeah,
too.
I want to talk about the water there. Hmm.
Yeah, water is definitely a key factor, but then we go even lower, like with something like this, and here we have, the much lower distance between the deck, and this was actually a railway bridge that's converted to a pedestrian bridge now at a
Mm.
park. So very interesting findings here too. And then there's this one. This one I go to a lot. It's really close to our office, and I use it for testing out new skills and new
Hmm.
things that we got. And actually, the recent one I just tested was the upward scan mode that Skydio just released.
Yeah, so this was in the summer release to the upward capture, I think it's called. I got this
Yeah,
right, yes. So it's basically, actually, you explain it, Des, because I haven't tested yet,
yeah.
but
Well,
you have.
anyone that's done any mapping with the drone, this is very similar to regular mapping, except it's
Mm-hmm.
inverted. And now instead of our camera pointing down, it's pointed up, which is great because the Skydio doesn't need any extra hardware to do that. Like the gimbal just looks up. So for us, awesome because it's really hard to capture this type of imagery if you want to reconstruct it. So we want to turn this into 3D uh,
And it
eventually.
also optimizes the data capture massively, right? Because
Yeah,
you're not exploring kind of like on a 3D environment, but you're just doing like a 2D plane
yeah,
capture. And
yes,
I'm curious about the results from this because of it's quite interesting the reflection of the water
yeah.
on that.
I was really thinking about that. So I've done a ton of testing on this, and I'm probably gonna have some LinkedIn posts just about the photogrammetry side of it. But this is the result, right? So you can see here we have the textured mesh, the 3D model with a texture, visual stuff from the images. But then we can also peel that off and look at just the geometry of the mesh, which is really
That's
cool. We can
amazing.
now see how bad that deficiency is. And
Hmm.
by the way, like typically we're going to go inspect this with video first, find where all those deficiencies are, and then if we want some extra information like this 3D data to be able to measure how bad it is, then we would go and selectively do a scan of those areas, not
Hmm.
necessarily doing the whole bridge for the inspection only because we might miss something that way too.
Yeah.
Yeah.
So we're gonna talk more in detail about the best practices,
Hmm.
but this is just kind of like a preview of this new functionality, right?
Yeah.
So we'll go over in detail about the 3D scan workflow, but it's very interesting, kind of like that link to the 3D modeling, because in bridge inspection, something that I learned recently enough is that it's not only about the 3D mapping. Actually, the imagery and the video captures oftentimes the key element of the bridge inspection. So I like that kind of like link between the data capture and the final deliverables.
Yeah, absolutely. Like you'll notice through this presentation, I talk about that
Mm,
a lot. We start with video, and then 3D is this like awesome value added
mm,
bonus feature that we can now do, which is awesome.
yeah.
But in terms of bridges, like bridges are hard. I use this scale to tell people a little bit about why they're hard. But we have like towers. Inspecting those super easy. I've done a ton. Inspecting wind turbine blades a little bit more complicated. You got to stop the blade, and there's a lot of technology out there, but it's still a little bit more complicated. And then buildings, I put those at like the 3 scale out of 4 because there's a lot of turbulence that happens up there as well, and you got to cover a lot of surface area. But the ultimate final boss is bridges because as you can see from this picture, like it's cramped, it's dark, it's not a fun place to be flying a drone.
Not a fun place.
Not at all. And the first time we did it, especially this bridge, we did it with a completely manual drone,
Mm.
and it was about 8 hours of really really stressful flying to be able to get this data.
Yeah, so something that it was told to me last week when I was on site on this construction. So they are constructing a massive bridge in Sacramento, and one of the guys was saying that they had to train drone operators to be able to fly drones manually in such environments.
Yeah, they're
Like,
really, really brutal environments. And even once you get the flying done, then you need to actually go and find the issues. And there's so many of them on bridges because there's so many different materials and
mm-hmm,
joints and elements. So you should be a bridge expert and a drone flying expert at the same time. So I think the most ideal person to be doing the field work is actually the bridge inspector themselves. Honestly, I'm in the service business, but I have to say, I'd rather not be the person doing the flying just because of how much you need to be on the lookout for. You need to be an expert there as well.
mm,
But yeah, so this is a little diagram I have just to show why bridges are hard, kind of get all the points in one shot. So this is just a cross section of a bridge, but we're already in a GPS denied environment under there, right? So we're under the satellite's shadow. We have lots of weird mechanical turbulence, right? It's usually in an area of depression, but there's a river or something, so we get some weird wind effects there. Close quarters, low light, those are no brainers. And then EMI, electromagnetic interference. The concrete is reinforced with rebar, and magnets don't like big pieces of rebar close to them. So, with most drones, they require some sort of magnet inside the compass to figure out which direction they're facing, and then GPS to figure out where they are so that they can keep that direction and position. And then there's also the problem of like a dynamic surface, that there's water moving under you. So drones also have cameras that point strictly down, and they're there to basically see if the ground is changing. That means I'm moving, so correct it. When the ground is constantly moving and changing, that formula breaks down really bad, and then there's obstacles which you could hit. So really, really tough situation overall. Don't like it. Don't want to be flying in there unless I really know what I'm doing.
yeah.
Yeah. Um, so what we do is with manual drones is we fly offset. We fly to the side of the structure, and even this presents some issues. So we have something called GNSS multipathing. So essentially, the satellite signal, as it's coming down, we want it to hit the receiver on the top of our drone, but unfortunately, it will bounce in some cases off of a structure that's nearby and then hit our receiver, which adds a lot of distance. It doesn't look like a lot, but really, when we're trying to get down to a centimeter or so, this adds a lot of travel time, and it's not a great experience. This even can degrade our position, right? Even if we're not
Mm-hmm.
exactly under it, we can have some compromised positioning even off to the side. So, and when you look at the manual, like we have something here called OSIM, the Ontario Structural Inspection Manual. It's basically the Bible. And this is what the inspectors follow. And right on the manual, it says in black and white, the inspection should be conducted within an arm's length of
And
the
just
element.
and just for clarification, this is
Yeah.
an arm.
Yeah. Yeah. And just a regular arm. That's a Canadian unit of measurement.
I, when we were preparing the presentation, I was like, is this a new
Yeah.
unit that I need to learn? I mean, between the foot and the arms, I'm just.
Right. So yeah, it's not very far. We need to be pretty close. And what happens when we're looking at from the bridge from the side, it gets pretty dark towards the center or the middle of it, and we can only zoom in so much. Our camera can only pull out so much resolution from outside the bridge. So we can get the data, but it wasn't great. So this was our experience in the first try. And I wasn't feeling too awesome about it. And then afterwards, when we got to the office, we had all of this data that we collected in picture format, and we had to organize it because everything looks the same. I think we covered this last time on the webinar.
Hmm.
Like, red bricks on a building here look like red bricks over there after a little
Yeah.
while. So same thing with bridges. If anything, even more complicated and more important to get it right. So this added a lot of time in the office organizing and sorting
To make
everything.
sense of the data. Hmm.
Exactly. Yeah.
Yeah.
So not a fun experience thereafter. Took a lot of time in the field and out at the office, and we had to be doing it with two people. Like, this wasn't a one person job. One person flying, me, and then the second person taking notes of everything that I was saying, what I would find, just so that when we got back to the office, we could do that organization. And it wasn't, it's a lot of manpower or woman power
Mm.
out in the field that you can try to reduce if you want to scale this out.
So this is um, okay. So this doesn't sound like a very fun job to do. So
Yeah.
enter
And
Skylio,
yeah, so
please.
the second time we went, I went and bought an S2 just off the shelf.
Hmm.
And I didn't think it was. I just brought it just in case, just to try it, really. And then we got it up there, and we started seeing this, and it just our jaws dropped because we couldn't believe how stable it was in those areas. Like we had heard about the obstacle avoidance, but we didn't think it was going to be this good.
Hmm.
Yeah, so you can see here, and this bridge is also kind of funny. It's two bridges. There's an older bridge and then a much bigger bridge built over top of it. So there's actually two layers, and the inner layer is the one we're really worried about because that's the older stuff. So this
Yeah.
allowed us to really clearly see what was going on in there.
So it's like I think the first thought for me is basically safety and the removing the stress from the drone operator, right? Like as in,
Hmm.
I think last week someone mentioned I wouldn't do this without a Skydio because I did it and it crashed my drone. Like
Hmm.
any other drone will crash
Easy.
easily on this environment.
Yeah.
We are not saying that we solve all the challenges. Lighting, someone was mentioning in the comments, lighting is definitely a challenge. So there's definitely an element that is a very harsh environment to fly a drone, but nevertheless, safety comes to mind. And the fact that you can put a Skydio in anybody's hands and they will be able to get some quality data in this environment, in these circumstances.
Hmm.
What else would you say about um,
Yeah, so you brought up light. I've never encountered a situation with Skydio where we didn't have enough light to navigate actually, and enough light to visually see in the inspection what we're looking at. It does a
yeah,
really good job.
you've been lucky enough, but
Hmm.
I do know that this is a challenge in other areas and in other
Yeah,
environments. But
I
yeah,
could
so
see that.
we acknowledge that.
Yeah, with GPS denied flight though, I mean that's the biggest thing. That's really
Hmm.
the main thing that we're after because we want to get into really tight spaces with 100% no GPS signal down there.
Hmm.
And then we also want to do it safely. So the autonomy that's always working is huge. It's not allowing us to crash. We could try to put it into a wall, but it will hold and stop and hit the brakes, and then we can always switch into those navigation cameras that it uses for that autonomy and get a live view. So this is also a really nice feature where instead of moving the drone around to see exactly where we are and where to go to next, I can just one button
You
pop
have
into
a
this.
sense, yeah, you have a sense of where
Yeah,
you are at all times, which I love that. Yeah, that helps
yeah.
navigation a lot. Um, and damn it, I missed someone was saying something and I missed it. Nothing. Keep going.
Yeah, EMI immunity. So immune to anything that would cause a compass or some sort of magnetometer to not function correctly
Mm.
means we can get into structures that have a lot of metal, a lot of steel. Something I would never really be able to do with any drone, even out in open space. I would be careful with it in this situation. And most drones won't even take off if you're too close to
Yeah.
metal. So.
Um, I want to read this comment because I actually we had a few questions regarding water, flying over water.
Mhm.
If the drone loses GPS connection and say we're over water, will it crash land itself in the water? How is your experience? Because you've shown a few pictures of
Yeah.
bridges.
Yeah, so here's a bridge. This is that pedestrian bridge that's very close to water.
Hmm.
This is how we're doing the inspection, right? We're taking a video, seeing everything, great, 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 run through, and this is how close we are to the water. And I wouldn't be confident to say that we have a GPS fix here. Probably a minor one, but not as what I would consider safe. And because there's a bridge over us and the Skydio is looking everywhere, 360, as long as that bridge doesn't move, it still has relative positioning, right? So I think that's how it's dealing with the water so well.
Yeah, so still water is a challenge, a massive challenge because of the reflection and because of different, yeah. So um, moving water is your best friend if
Yeah.
you're going in this kind of like in this case, I think that that was a good example. It's a beautiful video, by the way, Ted. I really like this video. But yeah, it's a challenge nevertheless. So I think that we can't say that water is, easy peasy. It's just, yeah,
100%. Yeah, for
yeah.
sure. There's always edge cases, but I mean, I've never seen
Mm,
a bridge over completely still water yet, and I'm always up close to the bridge anyways. If I was flying middle of the ocean or like a lake, then yeah, I would maybe consider it. I would be careful, but
mm,
you're probably not going to lose GPS in that environment anyways, so it has
mm.
that to fall back on.
Any comments on this topic or any questions that anyone has, please, feel free to drop a comment. Um, Another aspect that I wanted to mention is the obstacle avoidance, because that for me, I think is not a very well versed in flying drones manually. I think that gives me a sense of like, I'm not gonna crash the drone, right?
Hmm.
So I think that would be also like a massive when you're flying in this environment, and knowing that, and also you have different settings, so you can do like
Yeah.
a closer obstacle avoidance to get into narrower, or more
Yeah.
confined spaces.
Yeah, I have a few examples of some really tight spaces that we got, but one thing that I also love is the ability to just hand launch and hand catch. Like
Yeah.
you were at a site with a bridge being constructed, there's not much space, it's really dusty. You don't really have always a position where you can set up and take on and off from there. So
And
this has been huge.
let me add that with the latest release, you can do that by pressing on the battery, switch on button. Like I think it's 4 times, and then
Hmm.
you can launch from your hand, so you don't need to use the controller anymore, which I think is a massive
Yeah.
advantage. Yeah,
I'm looking forward to trying that. I haven't tried it yet, but you
yeah,
can see one hand's on the controller because I want to make sure that I'm hitting that button. I can get a little bit clumsy sometimes.
yeah,
Yeah.
exactly. So now you wouldn't, have to have one hand pressing the controller. It would be just only on the drone.
Exactly, exactly.
Hmm.
So here's again that first big bridge, and this is a video from that first time. So traffic is flowing. Nobody knows we're doing this. We're not disturbing anyone, and we're under the cars, so very safe. And we just pop in there and start poking around, looking at everything that's interesting. And this again, this the autonomy here, the obstacle avoidance is working. It's doing its thing, but I am controlling the drone in that case, right? So it's not flying itself. I haven't told it to do anything like it does with 3D scan, for example.
Hmm.
Uh, and the same thing here. This is just a more constrained area that we're trying to get into. What I find is the Skydio, you ask it to go forwards, it'll take a moment, it'll figure out its surroundings, and then if it likes it and if it thinks it has enough space, it'll pop through. So there's really no ambiguity. You can definitely once you're used to how it flies, you can definitely tell what it does like and what it doesn't like because it takes its time with areas that it thinks is a little too tight.
And tell me, what's the data that you are, because obviously this all sounds like very hardware,
Hmm.
yeah, okay, we have a very, good piece of hardware and
Hmm.
software obviously for the autonomy, but tell me about the data you're capturing here, like what.
Well, there's really no other way to capture this data unless you have, right?
Okay.
Unless you have what we call like a bridge master, that reverse boom lift. Yeah, we're gonna get close, but you're not gonna crawl through that space. And you can see in some of these cases, we can't go through those spaces either.
Mm,
But it's definitely more than enough, and it's way better than what engineers have been doing thus far with the options that they've had, right? Um, Plus, nobody's in harm's way. It's super safe. It's a small aircraft, and if even if it does touch the bridge, it's not going to do any damage to it. And I'm not out tens of thousands of dollars, right? So in this example, we actually have two drones, two inspectors doing both sides at the same time, and we just crushed the inspection in terms of time it took us to
mm.
to collect this data, which gave us a lot of extra time to do some 3D scanning of this bridge, which I'll show you later.
Okay. I have a question here. Sorry,
Hmm.
this was at the beginning, so I missed it and I can't show it. Apologies for that. What is your go-to capture distance to yield the best results? That's an interesting. I think we were
Yeah.
so the go-to capture distance, and I also want to ask about the safety. distance
Yeah.
to object, I think it's called, or what's it
Yeah.
called?
What I like to do is with a visual inspection like this, like to get wide shots and close shots because engineers ask us for this. They want to know context. The nice thing about videos is that they can just watch it through and they don't
Hmm.
have to really do anything except watch in order to figure out where they are. But if there
Hmm.
is something that's really hard to see, we can get up to I think 3 inches with the close obstacle avoidance, which I actually don't ever use because what you're seeing here, this video, like this is very compressed. The raw 4K video is incredible and you can extract frames from it, like pictures if you want.
So three
So
inches is about 7, 8 centimeters, something like that. Yeah.
yeah, yeah. So it's more than enough. Generally, I because the video is so good, it's fine. Now, if we're doing like a 3D scan, then that's a really different situation because if you were doing a 3D model, that's probably because you want to measure something,
Yeah, and just
right?
just want to make the clarification for people not familiar with the 3D scan is the software that Skydio provides for the data capture, and then capturing that data for 3D mapping, so 3D modeling in photogrammetry platforms. So we'll
Hmm.
talk about this soon enough because we are 25 minutes in.
Yeah.
But yeah, so it will be so safety. Tell me again about the distance to objects because I know
So
there is
if
also.
the thing with
Mhm.
bridges is a little secret for everybody, and a lot of people here are engineers, so they understand this. It's not like if we're looking for like really high resolution stuff, it's probably because you're looking at a crack and you
Mhm.
want to measure it. Guess what? No, nobody really cares about the length of the crack. It's all about the width of the crack. That's what defines sort of the severity of it in their inspection manual. So if we were doing a 3D model, then yes, I would be interested in getting as close as possible. But if I'm doing a video, which I can't measure from anyways, then it's not super duper important that I'm that close unless I absolutely have to be. And I always feel safe with the middle of the line obstacle avoidance. Yeah.
Okay, amazing.
So here's an example where with a girder, like I could be flying through those girders and doing this inspection, but I
Mhm.
don't because I can knock two sections with one flight, much more efficient, and I have tons of information here to begin with. If there's something of concern, I can get in closer or I can do a 3D scan of that area specifically.
Okay.
Yeah. So yeah, let's talk a little bit about more 3D, right? So here on the left, you have our 3D model of this pier that we made, and you can see how easy it is to navigate. This is I'm using Nira to show this, which is one of my favorite applications for sharing 3D data. And then on the right here, you can see the equivalent of how we would be doing it with just video. So I don't know. You tell me, like, what would you rather have if you wanted to get in and do some, some really close up
Well, I might be
inspections?
biased, but I will go 3D all the way. But I also understand that it's different. Um, in bridge inspection, imagery and video would be kind of like
Yeah.
a very valuable asset
Yeah.
for the inspectors and the 3D model. And I think the industry is moving into that what they call these days digital twins. So having that data linked to one single source of truth. So I think,
Mhm.
the 3D model adds massive value. Um, and I think slowly every company is kind of like jumping into that. But for the time being, obviously images and videos and 3D models in this
Yeah.
case. Yeah.
And you can see here we're behind the pier. The pier is actually
Hmm.
hollow on the inside. It's very dark in there, and even the video is really it's perfect. Like it's more than enough
Yeah.
in order to see that information. We're not going to essentially always be 3D scanning all the nooks and crannies. But for areas that you do, you have that option, and it's on the same hardware. You don't have to go pull out something else. It's right there. It just takes a minute to set up and change between the modes.
Hmm. There's a few. I'm sorry. There's a lot of comments coming in, so I'm focusing on the conversation rather than the comments. But I'll follow up, and I
Hmm.
know my colleague Andre is also helping with this. So bear with us. But
Yep.
I've seen a few comments around control points and tie points.
Yep.
Um, so
Lux,
maybe
I'll talk about that coming up. That's a very
okay,
good point. I see that
yeah,
we have some people here that know what they're doing, so I love that. Yeah,
yeah.
if you want measurements to be accurate, you should have them controlled, right? Everybody knows that, and there is a way to do this with bridges as well. I've seen some comments about laser scanning. And I agree. Laser scanning has a lot of value, but the tough thing about laser scanning is it doesn't provide you inspection, doesn't provide you visual information. It just gives you the
Right.
structure, right? It's
And
just
you
a
need to
point cloud.
walk around. Uh,
Yeah, and even if the drone had a scanner and it was doing SLAM in the air and doing a nice map, like for an inspection purpose, that's not valuable because I need to see physical,
mhm.
colors, and point clouds don't give me that very well.
And so when it comes to control points versus type points,
Hmm.
so if you don't have control points, obviously your data is not going to be geospatial accurate. So you're going to have relative accuracy, which
Hmm.
oftentimes is enough for volume calculations or measurements
Yeah,
and things like that in a relative space. But if you need geospatial accuracy, absolute accuracy, you do need control points.
yeah.
And we will cover a few best practices. We're going to be doing a second LinkedIn Live because we know that Ted and I like to talk a lot about photogrammetry. So we're splitting this session into two. So we'll be covering the processing and photogrammetry side in a couple of weeks. So
Hmm.
we will cover some best practice for control points because we've been getting a lot of questions about that. But maybe very briefly, Ted, if you wanna
Yeah.
how you do the control points when
What
you
I
do them.
Yeah, what I would say is it always starts with a plan. In
Mhm.
terms of accuracy, okay, if you don't use control points, you could have really good accuracy, but you don't know that. You can't test that theory, right? So you don't know if what you have is right or wrong. If you have control points, you can test that theory and then constrain it to those points. The other thing you could use, it's not always just control points. You could also use scale constraints. So these
Yeah.
are like a ruler, you stick it on the surface, and
Mhm.
then in the post processing you tell the software this is a
This is
meter.
the distance. Yeah, yeah.
Yeah.
I use that a lot because for rapid mapping and I think that's a very good practice. Context capture, for example, allows to do that very easily. So you
Yeah.
can measure a couple of tie points as they are called. So you
Hmm.
literally measure them and then say, as you said, Ted, this is like a meter or 2 meters or whatever.
Hmm.
So it's a very good way to have that extra accuracy in your data set.
Yeah. So again, it always starts with a plan. Make sure you have plans for controls, but then also make sure you have plans for how to capture this 3D scan. So with this
Good
model, I
point.
used a Skydio S2 Plus with 3D scan software on it, and I subdivided this half of the bridge into 5 sections that I set up for scans. So you can see the red section, green, yellow, orange, etc. And the idea there is that I want to use as few batteries per scan as possible, and then I also want to make sure that the ceiling is strict. And sometimes these bridges are on a slight grade. So what I set a ceiling here, it may actually be above the deck on a down range. So that's
Hmm.
sort of a safety thing. But yeah, having overlap between these sections will result in better photogrammetry.
And tell me, because I do find this a little bit challenging. I think this is something that we could definitely improve from a software perspective. Just kind of like, how do you do this? Do you just kind of like visually say,
Yeah.
block one, block two, block three? Do you do this in the office? Do you do this in the field?
Yeah, I think about it ahead of time for sure, because one thing that I've noticed is that if I'm doing a scan, let's say I'm doing this red section first, I want to make sure that the drone is more efficient. So it'll basically scan like this. If you see how
Hmm.
my mouse is moving. Now, if I
Yeah.
set a section between these two piers with this arch, what it would actually happen, the drone would fly across to get the slice, and that would burn a lot of energy in going from one pier to the other. So why do that? Where I could just scan one pier at a time with half of an arch, and then the other pier, second time, another half of
Hmm.
the arch, and then combine them.
And can we mention, maybe not getting into nitty gritty details, but
Hmm.
how do you do this? Because different software packages in terms of photogrammetry behave
Yeah.
differently with this. So how easy is to then fit the tree or the different blocks
Hmm.
in one single 3D model?
If you have good images, it's not that hard. So with this, I
Okay.
had about 3,800 images, and I was able to recreate this model in about 4 different software packages because the data going in was good. I used, I
Hmm.
believe, a 75% overlap on here, and I was, I think,
Did you
4 meters
did,
away.
did you use how much?
75.
75. That is
Is that okay?
I'm educating myself on this because I contest capture was always like 80-80. So in the last webinar, Ted was like, oh no, 70-70, you're fine. 75, okay.
I've done it with
Okay.
70, 70. Things start to break down around 65, I found, is where you're really
Yeah,
pushing it. But I just
yeah.
did some photogrammetry at 60, 60, which worked great. So it really depends
Wow.
on the scene. Um,
we should cover this in a different session, but
Oh,
yeah, yeah,
there's a lot of intricacies. So I think this is where people get hung up as well because 3D Scan collects the data for you. You still have to turn it into a model. There are a lot
mm,
of really great cloud packages for like one shout out for GeneX. They have some incredible photogrammetry in the back
yeah,
engine and they created this in no problem in one go with the same images and actually had some better results than what I was able to do with desktop stuff. So
yeah,
there's a lot of options out there. It's definitely growing.
yeah, definitely.
Mhm.
Cool. James Mansfield actually made a comment. Nice to see James here, but I just wanted to highlight I couldn't agree more. Always have GCPs, even if you don't think you need them. It always helps if you can verify your position and scale.
Mhm.
I agree with James when it's necessary. Like I also think that sometimes relative accuracy is good enough for certain applications. So it always comes down to what you need to do in the office with
Mhm.
that deliverable, and then reverse engineer from there. So
Mhm.
when it comes to things like overlap, things like counterpoints, think about your final the requirements for your final deliverable, and then plan your mission accordingly.
Plan ahead, yeah, absolutely.
Plan
So
ahead.
here is 3D scan being done. This is just a screen recording from my iPhone, which was running on the controller.
So
So
this
I'm
is say again. So you are using your phone on the controller, and this is the application. So 3D Scan is the data capture application that Skydio provides,
yeah.
and this is kind of like the workflow that you do to do that
Mhm.
3D capture. Okay.
Yeah. Yeah, so the way that we run out in the field, we have one Skydio without 3D scan and then the other one with 3D scan, and we have both of them on the autonomy enterprise so that we have closer obstacle avoidance and upward view. So we do the inspection with both, and then the areas we need to 3D scan, we send out our 3D scanner Skydio and do this part with it. So you're just seeing what I was doing in the field after we finished the visual inspection to do
Yeah.
a
And
model
this
here.
is, sorry, I remember now what I wanted to mention in terms of the challenges. It was the geofences, so that you don't fly over
R-
the bridge, or like, you don't interfere with traffic. So that's
Right.
sealing.
Yeah, I just skipped that slide, but let's talk about that specifically because I've seen some people with questions about
Yeah.
geofencing. So again, the floor could be important, especially if there's a traffic underneath you or pedestrians. You probably don't want to be doing this in that case, but it's there and it's helpful. The ceiling is the most important because again, there's traffic up there. This is a really great way of setting a max height essentially
Hmm.
so that the drone never breaches this altitude.
And I love this because it's not like you're flying the
Yeah,
drone.
you
So
see it.
you're actually, because my sight is really bad. So I say you fly the drone and you're like, okay, you're at the exact same level that you don't want to
Mhm,
fly over that.
mhm.
And then you set that, and you can also interact. So what you're seeing on the screen is basically that interaction with augmented reality. So you can touch the screen and also modify that if required.
Yeah,
I yeah.
I'll show you that in a second.
Yeah.
The thing for me that I love here is that I don't have to type in a number of
Mhm.
how high I think the deck is. So I need to measure it somehow from my launch point, which can change, and I have to redo that and then plug it in. This is just visual. This is literally where the drone is. Don't breach this altitude, and I love that because I can very quickly do it, and I can be assured that it's going to
Mhm.
stick and it's going to be in the area that I want without actually having to find out later. Someone just asked a question: why is there no wind in this inspection? I've never been under a bridge without wind. But there is
I
wind in
was
this inspection.
I was reading that and I was like, oh no, no, there's gonna be a lot of wind.
There is a lot of wind. That's the thing. It's like it's always there. Even on a really calm day, there's wind inside of a bridge or underneath a bridge. It's crazy.
It's
Uh,
yeah. Once you see the S2 plus flying on wind, is it's pretty impressive. Like how it navigates, and even in windy conditions.
Yeah, so let's
Cool.
let's go through this. So here we're setting the
Yeah.
boundaries for the 3D scan. We're telling it what area we want to scan inside of. And again, the autonomy is working. I can freely fly through the bridge to set these points. I can set them regardless of my GPS lock or not. It still knows where that point is because it's mapping its environment in real time,
So what
which is
you're doing
awesome.
here is basically flying the drone. So it's defining the volume, your object
Mm,
of interest.
that's
So
right.
you're setting those pillars which will define the area or the volume of that
Hmm.
object within that object of interest. And so you fly the drone, and then with that augmented reality and 3D scan, you basically set those set that boundary.
Hmm.
between the screen and flying the drone. So I love this. I think it's a very easy and intuitive way to define your area of interest.
Very easy. And the other
Hmm.
thing here is you're starting to see these settings for the geofence. So strict
That's
ceiling,
the one.
make sure
Hmm.
that one's ticked on. Strict floor can be optional. I do it in this part because there's some machinery there. First of all, I don't
Hmm.
want to map that stuff, and I don't want to get close to that stuff.
Yeah.
Strict walls, I don't check off here, which I probably should have, and you'll see why. But at this stage, I'm ready for it to just go and explore. So I've told it a boundary of volume, but it doesn't know what's in that volume. It has to go figure that out by itself. So every time you do this, you could get slightly different results, but it always impresses me, this section, this
Yeah.
part right here. And we're fully autonomous. So now I'm not controlling it. I'm not controlling
Yeah.
the drone.
So basically now it's exploring. So it's gonna do a very quick flight, and it's gonna kind of
Hmm.
like get a sense of what the object of interest is like, and then it will come back to you and say, okay, now you can define the overlap. Oh, what's happening here?
Yeah, so what happened here is if you notice, there was the pier that I'm interested in, and then that's inside my volume. But then just outside of it is the spandrel, right? These spandrels are these vertical columns from the bottom chord to the top chord of the bridge. And it went behind it during its explore phase, and it basically said, if you want me to go across and go back to that area where you're interested in, I need to break that geofence. I need to break that wall.
Hmm.
Okay, so at this point, I'm like, okay, I need to do something on the controller. So what I did is actually take over. So 3D scan's still running, the explore phase is still on, but I take over and I basically move it a little bit into a position where it can continue to do its exploring. So I'm just on the sticks here. I overcompensate there, and then as soon as it sees an area that it recognizes, like the surface, which it was mapping, it kicks back on and it continues that scan.
That's very interesting. Yeah, yeah. So you could ignore the geofence, meaning oh, I wouldn't do it in this environment, obviously, but you
Hmm.
could do if you have the safety to do it, if it's safe to do it. But you took over manually, and
Hmm.
then once it was just out of that, uh, yeah, it got back to like knowing what it was, then it
Hmm.
continued.
Yeah.
That's
So this is also a very unique example with bridges. Like you're really not going to see this example with structures or towers because there generally isn't anything too close to you.
mm,
Bridges do have this situations, so again, why they're hard. What I also did here is after I got back, after it completed its explore, I realized that it didn't do a great job because of that whole thing that happened. And I actually told it to go explore again. But what you'll notice as I go back here, exploration, restart exploration, what you'll notice is that that mesh over the structure is still there, so it's
it's
still
already
retained.
there.
Yeah, it hasn't thrown everything out, which I really appreciate. It makes this step a lot faster because it doesn't have to start from
So it
scratch.
doesn't start from scratch. Oh, that's
Yeah.
interesting. I've never experienced this. This is a really good trick, best
Yeah.
practice.
Very, very helpful to know, and to know that you can just do that, right? So here we go. Now I set up the scan. Let's see if I do something controversial here. Okay,
That's
75,
fine.
75.
I mean, in
Distance,
fairness, in fairness, that bridges
that's
in terms of
fair.
like the surface is quite easy
Yeah.
for the photogrammetry, like concrete. Except for the light conditions, shadows might be a
Yeah.
bit, yeah,
Good point. Yeah,
yeah.
like the material isn't reflective, so photogrammetry works well,
Yeah, yeah,
right?
yeah.
Yeah.
So 4 meter distance to surface, that's gonna give you 1.7 millimeter DSD.
Mhm.
Amazing. And you're gonna use only one battery. So I'm looking at the right side of the screen.
Yep.
That's where the 3D scan tells you, okay, I'm gonna need like 148 pictures, 1.7 millimeters, 4 minute flight, and one battery. And it's gonna do that fully autonomously. So
Yep.
you're gonna just fly, and it will go and capture data on its own.
Easy peasy. Yeah. So yeah, I
Easy
want to keep it
peasy.
to about a battery, and I'm not like now I'm adjusting
Of course.
the distance to get some more photos. I thought that was a little too fast. Like we have a lot of battery. I don't need it to be done in 5 minutes. So let's get some more resolution. Now it's at about 6 minutes, and then
Mhm.
it starts collecting the data that we need. So it does this
Mhm.
for the entire section that I requested it, and then at the end it also asked me if I want to do some manual data collection, which I actually did in this example because I wasn't happy with how low I set that ceiling. I should have probably set it a little bit higher next time. Uh,
Yeah.
but but you always have that option to do some
Yeah.
extra.
Yeah, yeah. And it's also like interesting, like I know for you, one of the key elements in the field is optimizing the battery time as much as possible. Obviously, time is money, and when you're in the field, time is crucial. but it's interesting that you also like find a compromise between overlap and
Hmm.
GSD. So knowing your requirements, if you are looking into, for example, no less than 3 millimeter, sorry,
Hmm.
no lower than 3 millimeter resolution, you can play around, that overlap and GSD size to
Yeah.
get the best, possible time, flying time,
Yeah.
capture time. Yeah.
So here's another example of that other bridge, the municipal bridge here, more complicated. We actually did a much larger scan, as you saw in that plan
Mm,
phase. But this is what I mean. You want to be in the center of the pier and halfway out in the arches, so that you optimize that flight pattern. It's not flying across the bridge to get from one slice to the
yeah.
other. Um, yeah.
So just kind of like to very briefly, and we need to wrap up in about 5 minutes, Ted. But something that I really like about this view is like what you're seeing here is the coverage. So
Hmm.
while Skydio is doing the 3D capture, you have a couple of views that will toggle between the coverage. So that means
Hmm.
the overlap that is capturing the data that is capturing and how the overlap grows.
Hmm.
And then also the flight plan, the flight path, which you show on the in the slide before. So you at all times have a sense of where the drone is flying and what data is being captured.
Mhm. Yeah, really
Yeah,
useful. So here in this example, looks like I used 7070, oops, and distance 4.5 meters gives me a resolution of about 2 millimeters. So when I'm thinking about the
yeah,
cracks, I'm thinking about what is probably the smallest unit of measurement
yeah.
that I would like. And here we're going to get about 2 millimeters as our smallest unit of measurement. That's essentially it, right?
Amazing.
Um, so again, same thing. After you set this up, the rest is all the same. Doesn't matter what the 3D scan object is. Bridge, space shuttle, same thing.
That's again the augmented reality. So
Yeah.
like those squares is where the pictures are taken. I've seen a couple of comments about the sorry, if you guys wanna, and gals, if you wanna scan the QR code on the screen, that will take you to the 3D model from TED.
Hmm.
And I strongly recommend you to have a look at it because it's quite impressive.
Yeah, I'll stick around for some questions afterwards because we're getting some amazing questions. I love these.
Yes,
But check out this model. Again, this is running on Nira. The nice thing, what I love about Nira is that I can do all the processing on different software and then bring it into Nira. And now it's not even like this model isn't even on my computer to render. It's on a
yeah,
server somewhere. So it doesn't matter what computer I'm on. I have access to it. I don't need a big fancy GPU. And
yeah.
so do you. So you're able to open this up on your phones because it's just video on your end.
And I want to again mention we're going to be covering all the photogrammetry, so data processing, photogrammetry, and 3D modeling, and some beam applications in a couple of weeks. So we will continue the bridge inspection, but from a processing, that might be a fun
Mhm.
one for you and I being
Oh,
photogrammetry lovers.
it'll be fun for me, that's for sure. We'll get into
um,
the nitty gritty. What I want to
yeah,
get across with this is that, like, look at how great having a 3D representation of this bridge now is, because when you see something like this in a picture, 2D, yeah, you get an idea of how bad it is. But then in a textured model, you can flip between textured and not, and you can see the level of detail that we can extract in terms of how bad that deficiency
yeah,
really is. And you can see these edges, right? So you can see that the abutment here on the pier is where that
hmm,
issue is between these two sections.
yeah.
Yeah, super
Um,
cool.
so let me read a couple of questions before
Hmm.
we finish the live. So Matt is asking, do you have metrics on how much faster a Skydio 3 scan inspection is than a traditional UAV inspection? We covered this in the last webinar. Ted did a very good. This is manual flight versus autonomous flight. I don't think we have a. I don't know. So I'm gonna check internally and see if I can find any numbers for you, Matt. But thanks for that question. And Matteo is asking, impressive number of photos, good job with manual flight in these conditions. How come you did not scan the whole bridge automatically? Um, Before I leave this to you, Ted, I want to mention that
Hmm.
after the 3D scan, you can also manually, so 3D scan will tell before finishing that flight, it will ask you, do you need to take any manual pictures? So you can add any manual
Hmm.
additional pictures, sorry. that you can take manually.
Yeah,
Um,
here's an example on the screen of that. So you can see the 3D scan images. Those are the ones that are
mhm,
really nice and organized and very equidistant from from the surface. And then you can see these ones. These are like me completely just smashing the trigger button, making sure that I get a lot of detail inside of these spandrels because that's where photogrammetry starts to really uh,
yeah,
break down as areas that it doesn't have enough overlap of. Again, lessons learned from this one is take manual pictures. And next time I would probably take many more manual pictures of these areas between spandrels, right? The
yeah,
nice thing is though that I still have data for those areas because what I can do is because these are just pictures, I can
mhm,
select a camera and then I can open up the actual photo itself and boom, I can still see what's going on
yeah.
in there. I can detect any real major issues. It doesn't have to be in 3D.
Yeah,
It's not like I don't have information there. I still definitely do.
I want to mention also the guys from Skyline, which is photogrammetry software I recently
Mm,
discovered in commercial UAV. They have a functionality where you can measure on 3D,
yes.
and it will be automatically visible in all the pictures associated to that measurement, which is really powerful.
Yeah, being able to measure from 2D images is what
Yeah,
photogrammetry is all about. So,
yeah,
once everything is aerial triangulated or AT'd, like what you're seeing with these cameras, we know where the position of the camera is, then you can do whatever you want. And then if you're really worried about accuracy, you go for control points, and
hmm,
then you go for constraints if you really can't
yeah.
get control points. But let me show you where some control points are on
Oh,
this one. It's really simple. See this little green mark.
spray, yeah.
What we did is we just sprayed a little visual spray paint, and then we got that point with a GPS rover, and then we got them at the base as well, a few different locations. So this is allowing us to make sure that the highs and the lows are all covered by those static GNSS observations.
I just want to mention, Greg, I will be following up on all your comments and questions. I know Andre is doing a great job supporting us, so thank you so much. But Greg, I do have an example of a steel trust breach. I'll share that with you.
Hmm.
Um, any other questions you wanna? Have you been? We have a lot of things here, but I'm mindful of the time.
Yeah, let's see. I mean,
Um,
I've seen some amazing questions here. Let's see.
Wait, this is an easy one. Which
Yep.
software was used to create the model? I think Tero uses every software package.
I have, I think, 7 of them installed on this computer. I was able to reconstruct this in, I think 5 of them. So this one, not a problem. There's other ones that I've had more difficulty in. It just depends on how you collected the data. Also, a big part of it is just like what the weather was that day, right? We want to reduce shadows as much as possible. And you'll see if I fly to the other section of this bridge, let me just go through here. This section was in the shade, so no shadows. And
Hmm.
then this section here was facing the sun at that
Yeah.
moment. So we waited for the sun to be almost as directly above the structure as
Yeah.
possible. So we reduced those shadows.
But
But
this is, I think there is an element as well that we need to be realistic here. Like we can't pretend like, Sacramento, California, like it's going to be sunny every day.
hmm
So I think this is also something that needs to be, happening on the software side. And they need to cope with these shadows. And I think they are already coping much better than 5 years ago.
oh yeah.
Um,
It's
yeah,
photogrammetry is getting so good. I'm
yeah,
really excited for its future because I can see that just around the corner we're going to have photogrammetry that's much more versatile and much more usable by people that haven't done it before. It's going to be
yeah.
very easy to break into.
But this, correct me if I'm wrong, but this 3D model, the one that we linked the QR code to, is made with context capture, is it?
This is context
Yeah.
capture. I found that in this example, context capture it actually delivered some of the best textures.
Hmm.
So I crowned it the winner, but the other four were really close behind. I was just being very, very, very
Yeah.
strict on the.
And just want to mention from a Skydio perspective, we're fully agnostic and compatible with most
Yeah.
photogrammetry software from Drone Deploy, Context Capture, Skyline, GNext,
hmm
Pick for
Nira.
the Nira.
Yeah.
So yeah,
And that's
if you
that's what I
have,
love. I don't have to. I'm not tied to an ecosystem because again, sometimes things work on one, don't work on the other. I don't want to be
Hmm.
vendor locked from this side of things, from like the actual photogrammetry side. I like to play around, and then I like to just test the same thing across many. So I love the combination of just doing it on my desktop. It's not hard. It's actually very easy. And then
Yeah.
throwing it up on Nira, which is what you're seeing here, and it's device agnostic now. The data is in the
Hmm.
cloud. It's very easy to share. But if you need to do this for a lot of assets, 100% a cloud solution is probably going to be better for you because it's
Yeah.
in one
Yeah. Yeah.
place for everything. Yeah, I
Absolutely.
can't
And
deny
I
it.
think we're also moving into that direction. So Skydio has Skydio Cloud data sync, so you can automatically upload the data into the cloud. We already have an API integration with Drone Deploy, which means that your data gets automatically processed immediately once it's available on the cloud. So I think the industry is moving into that direction, just removing the need to have an operator uploading and downloading and clicking buttons like
Hmm.
a yeah. So I'm seeing a few questions there. This is really interesting regarding accuracy and best practices for photogrammetry and control points and accuracy and these things. So we will be covering those in a couple of weeks or maybe 3 weeks. We'll need to get our agendas in sync again. But yeah. So any comments or remarks, highlights, Ted, before we say goodbye?
I there again. The purpose of today was really to show you guys how we do the data collection, the actual field work, and how this has really completely changed that. There's areas like this where we were never really even we weren't going to go there, like at an underside of a girder, slab on girder, like we weren't even going to try to inspect it like with a drone before. Now we can, and then now we can even do this 3D scan, which I would love to talk way in depth on in the next one. But at the end of the day, it starts with a data capture. Like if you can't collect data well and effectively and efficiently, so you can do it over and over again and not have $200 an hour pilots that are only capable of doing it, then that's the big win. That's where we're able to really get the demand for 3D data that we should be seeing, because it's absolutely valuable, right? You can get so much more info from it and then store it so you can compare things over time. It's much easier to compare things when they're geospatial and you're doing it
Yeah.
over and over again. That's even more value starts coming out that way.
Yeah, is the repeatability, is the safety, is the I wouldn't be flying a Sky. Sorry, let me rephrase that. I wouldn't be flying any drone unless it's a Skydio under this, in this environment. This is the
Hmm.
reality. So it's kind of like it's removing the stress of the drone operator and allowing anyone to be a photogrammetry and gathering quality data in any environment safely and so I think that's one of the biggest things that I wanted to highlight.
Hmm. Do you want to? So
um
one thing that I want to add as well is that sometimes the problem can also be getting all that data from the drone into your computer and just making sure, because like you might lose an SD card and poof, there goes your whole
yeah.
inspection. So there, I've seen Skydio Cloud. I haven't used it before, but I can see that being a big win for organizations or companies with a lot of these drones. You really got to keep things organized, and the ability, I think it can just upload straight into the cloud into something like Drone Deploy or one of those cloud softwares. That's pretty awesome. Um, Definitely value there as well.
Yeah, that's a very good point. Well, Ted, anything else?
I got a lot more, but
I
we'll
know. I was like, I know there is much more we want to talk about, but feel free to suggest any more topics you want us to cover in webinars. I like, Ted loves doing this so much, so like I'll just keep doing these live events, more often if it's relevant. So, Ted, thank you so much again. Thank you everyone for joining. I'll be following up on all the questions and comments that you had.
Yep.
I'm sure Ted will help with that too.
Yeah, if
Um,
anyone has any like photogrammetry, or if you have like a data set that you're having trouble with, let me see it. I'd love to explore and see if I can help you with it in preparation for that next webinar. We might
and
actually
I'll
be able to
be
get some good examples.
yeah, and I'll be helping with all the Skype related questions. So thank you, everyone. Have a lovely weekend. We're almost there, and we'll see each other very, very soon. Thanks.
Bye
Thank you,
bye.
Ted. Bye. Bye. Bye.